AMC 8, question 23. How many four-digit numbers have all three of the following properties? The tens and ones digit are both 9. The number is one less than a perfect square. The number is a product of exactly two prime numbers. So again, a very typical number theory question. Very interestingly, the last 5 questions for 2025 includes quite some number theory questions. 21 is sort of a combination, but 22 is number theory, and 23 is also number theory. So let's take a look. So four-digit number means the format of this number is A, B, C, D, 4 digits. Now, the 10th and ones digit are both 9, so you get it's actually AB99, something 99. Now, the second condition is saying this is actually something square minus 1. This gets really interesting. Before we move to the number is a product of exactly two prime numbers, because something square minus 1 equal to AB99 means that some square is something in 100. The reason I put something here is because I don't know if this is going to be 2 digits or 3 digits in the first before you get 00. But if something ends with 99 plus 1, you're going to get something times 100. So a number square is some 100. That means this n has to be ending with a 0, or this means n equal to nk. And that's the first part, which gets this question really interesting. Ends with 99, and it's a square minus 1. That means the square has to be something times 10's square. And because it's 4 digits, you can easily check the only possible ends are going to be 40, 50, 60, 70, 80, 90. Now, how do you know if it satisfies the third condition? Let's use 40 as an example, and here we will be using the diff of squares. If you don't know this equation, take notes. Super useful for algebra, number theory, even some other geometry questions. So a squared minus b squared equal to a minus b times a plus b. To prove it, you just expand it. You will find the AB term gets canceled out so very nicely. A squared minus b squared is a minus b times a plus b. Now let's take a look at 40 squared minus 1. So if n equals 40, 40 squared minus 1 is equal to 40 minus 1, because 1 is the same as 1 squared, times 40 plus 1. So this is going to be 39 times 41. And this one doesn't work because 39 is not a prime. So we can continue on. 50 squared minus 1 squared is going to be 49 times 51. Well, 49 is 7 squared, so it doesn't work. 60 squared minus 1 equal to 15 times 61. Those two numbers do not have sum factors easily coming to my mind or your mind, to our mind. And you can do a quick check to confirm it's both are primes. So this one actually works. Now 70 squared minus 1 equal to 69 times 71 doesn't work. You'll find multiple of 3 is an easy standard to confirm something is a prime or not. 69 is a multiple of 3. 80 squared minus 1 equal to 79 times 81. Well, 81 is 9 squared, so apparently not a prime number. And 90 squared minus 1 is 89 times 91. This is an easy to miss point. because some people may think 91 is a prime number. It's not. 91 is actually 7 times 13, so this is not a prime either. So the only number that works is 50 squared minus 1, or 2499. Answer is B.